Greetings, everyone. Here's our the first model, and that one is a general use of Garmin G1000 and GTN 650 XI for search. So different search patterns using just the basic features of the avionics. And we will cover route search, grid search, expanded square search, sector search, and creeping line search. Let's start with the route search. As you probably know, if not, I will remind you that a route search is when you search along the track of a missing aircraft, and usually that track is known because the pilot filed a flight plan, or maybe there is a good reason to believe that the pilot flew direct from one airport to another. And in this search pattern, you would fly the route, but you will fly it with an offset. And when you finish the route, or at least the section of the route where you were tasked to look for the airplane, because that's the highest probability to find it, you would fly the route in the opposite direction. And when you flew the route forward and backwards, then you would reverse again, and you will fly it forward, but you will increase the spacing. And you can see on this picture that even though it looks like you're flying left and right from that route, from the original track, but from your perspective, you will always be offsetting to one side. So in this example, you start with the offset to the right, and when you finish this leg, or this offset, you will cross the route and then fly back. So from your perspective, you would be to the right of the track again. And then in the end, you will cross the track one more time and then fly it again to the right, only this time your offset would be bigger. And you can notice that you will increase your offset every time you going forward, or every odd pass. So 1, 3, and so on. So how would you do it in Garmin avionics? And you will notice that most of the illustrations are made using GTN 650 XI, just because it was much easier, since there is a free simulator that is available online. So it's really easy to take screenshots. With G1000, there is nothing free available, at least for PC. I know that there is an iPad version, but it was just easier to make this presentation using desktop rather than an iPad. So how would we do a route search with the avionics? And everything is, all that information is applicable to G1000 or G1000 NXI. It's just the only difference is that which buttons you will press and which interface you will use, but conceptually it's the same thing. So first you will create a flight plan. That's the route you need to use. So in this example, it's University Park, which is now State College Regional, then Phillipsburg VOR, and then Indiana County Airport. When the flight plan is done, you would press menu, and then you would select parallel track, and now you need to select your offset. So remember, I told you that from your perspective, you always stay on one side, and you would increase your offset every odd pass. So let's say we want to do to fly a right offset. So you would select right here, and then you would select your offset, and that's something you would be tasked with. You might be told that your spacing would be 1 nautical mile, or in this example, the spacing is 2 nautical miles. So you would start with 2 nautical miles, and then you can see that now you have dash P on your waypoints, which means parallel. So that's the indication that that's a parallel track. And you can see that in 650, you will get those triangles that would guide you to your offset. In legacy G1000, you would just get an offset track, which you need to intercept manually. And when you're on that track, you would just follow it. And keep in mind that your HSI is centered when you're on the offset track. So I know sometimes people use the HSI to do offsets. Like in terminal mode, 1 dot is half a mile. So if you want to do 1 mile offset, you would put your center needle to 1 dot. If you want to do 2, you can either switch to en route when 1 dot is 1 mile, or if it's terminal, then when the needle is outside the range, you will see a cross track like it's shown here, cross track 2 nautical miles. However, when you use this offset, then you can fly with needle centered, which is more convenient. And as a bonus, you can use your autopilot, which will just fly this offset route as it would fly a normal route. So after the needle is centered, you would just fly it all the way to the end. And then you need to do several things. First, you need to invert the flight plan, because now you would be flying it in the opposite direction. After that's done, so we would be flying that part. And after that part is done, we will have to create an offset track again, because when you invert the flight plan, it will remove your parallel track. And remember, if you're flying it back, you will not increase your offset, but when you're flying it forward again, you will add your spacing. So if you started with 2 nautical miles, now your spacing would be 4 nautical miles. And here's an example how it would look in a G1000. So when you are in flight plan, on a flight plan page, you will press menu button, and then in this pop-up menu, you will select parallel track, and then again, direction, left or right, and then distance, whatever you want. Unfortunately, the minimum you can do is 1 nautical mile. So that's a limitation, but everything above 1 mile should work. Now let's move to grid search. And grid search, as you know, CAP developed a grid system. So instead of using latitude, longitude, or other coordinate system, you just can fly a grid, which is you can see it in ForeFlight. You can also turn it on for Flight Plan Go. Garmin Pilot also supports it, but the last time I checked it, only the Apple version had Cap Grid. Maybe they added it to the Android version as well, because usually features show up in the Apple version first, and then over half a year to a year, they will trickle down to the Android version. And of course, you can grid a sectional the old way, but I doubt anyone does it. So the first thing you need to do is to determine the coordinates of the grid corners. And then when coordinates are determined, you can create user waypoints with those coordinates. And I highly recommend to name those points as northeast, northwest, southeast, and southwest. And you would use NE for northeast and so on. So when you created the waypoints, you can add them to the flight plan, and then you can see a box on your map. And I highly recommend this website, capgrids.com, because you can enter well, you can do several things. Well, first of all, you can enter latitude and longitude, and it will tell you which grid this point would be in. And another thing you can do is you can select a grid you want, for example, Detroit 413 Charlie, and then you will get a picture with the coordinates of its corners. You'll also see it on the map. And you can download this. So if you press Google Earth Grid Overlay for Detroit, you will download a KML file which will contain the grid and also the sectional, the Detroit sectional. So you can open it in Google Earth and see it in Google Earth, which sometimes is very convenient. Right, so after the points are in, what you would be using is the OBS feature of your avionics. And to turn the OBS on in 650, you would go to default nav page and then press OBS. In G1000, you would just press OBS soft key on your PFD. And just as a reminder, in OBS mode, you can change course using the course knob, much like you would change a radio of a VOR. And also in this mode, your points will not secret. So if you fly over a point, you will just continue flying past it on the same course. So you will have a line which goes, well, I would say into infinity, but there's probably an end to it in the avionics if you will zoom out enough. But that's just a line which you will fly, and then if you are flying towards the point, it would give you to indication. If you passed it, you will have from indication, much like with a VOR. So now when you have all the corners in, you can select which corner you want to start from and start navigating to that corner. And in this example, it's a northwest corner. So you need to, when you reached the corner or when you're close enough and you're ready to align with your course, you would set the OBS to the proper course. And by proper, I mean, well, first of all, you need to decide if you want to fly it west to east or north to south. In this example, it's west to east, and that means you need to enter the proper course. Remember that the cap grid, much like your sectional, is aligned with true north, while our avionics is aligned with magnetic north, even though you can change it in the settings. But in my experience, it's much easier to add the appropriate variation. So in this area, it's 11 degrees west. That means if you want to fly on a true course of 090, you would add 11 to it, and it will give you 100.01 degree of magnetic course. And when it's entered in your OBS, now what you would use is your course deviation needle. So when you start the grid, if you want to start it right at the edge, the needle would be centered. And then as you finish the grid, you will turn around. I personally change the course to the reciprocal. And so that would be 281. And you will use your course deviation needle to be off by predetermined spacing. So if it's half a mile and you're in terminal mode, remember in terminal mode, 1 dot is half a mile. In en route mode, 1 dot is a full mile. So if you want to fly half a mile offset, in this situation, you would put your course deviation needle to 1 dot. If you want to fly it 1 mile, it would be 2 dots. And then when you pass 2 dots, you will use your cross track to make it whatever you need, 3 or 3.5, so on. The way you would maintain this course is your magenta diamond. Remember that our Garmin avionics has magenta diamond, which tells you what ground track you're flying. So in this situation, the ground track is aligned with the heading. That you would get only if there is no wind or you have direct headwind or direct tailwind. Most of the time you will have some sort of a crosswind component, so you need to make sure that your heading is set the way you would fly the proper ground track. So in this situation, you want to fly a ground track of 101. So whatever heading you need to maintain to stay on that ground track, you would bug it and just fly it. And here's the highlights. So that's your part of your OBS track before and part of it after. I also like to use, because you have some, you can customize your fields in all 4 fields are customizable in 650. In Garmin G1000, you can only customize 3 fields on your MFD, but in any case, you can select desired track and true track, and that's another way you can make sure that you're flying proper track. If your desired track matches your actual track, that means you're flying the proper course. And then I already mentioned that the second option is to use the diamond. Now let's move to expand and square search. And if you look at CAP publications, they will tell you that the expand and square search is when you fly one leg, then you would turn left or right, left in this example, fly for the same distance, and then you would add your spacing. So in this example, your spacing is 1 mile, so you would add 1 to 1, you'll get 2. You will fly another 2, then you would add your spacing, which is 1 mile, you'll get 3. You'll turn left again, fly another 3 miles, and then you would add again, and it would be 4 miles. However, that way of thinking is not very simple, and it will not help you with Garmin avionics. However, what is a much better way to do it is to think of your legs as legs that are offset from a point by a certain distance. So, and in this case, so you would start with 0. Well, you fly over the point, and then after a mile, you would turn, and you would be 1 mile offset to the north, or to the right from your perspective. Then you will turn again, and you will still be 1 mile offset will turn again, and then it would be another 1 mile, and you will turn again, and it's still 1 mile. So you can see that here you're all offset by 1 mile, and it just the direction changes. And when you are back on your original heading or your original course, more precisely, then your next offset would be plus your spacing. So now you'll be 2, 2, 2, and 2 again, and then the next cycle would be 3, 3, 3, and 3. So you will repeat the same offset 4 times. So now how would we build it in using Garmin avionics? Well, first of all you need for expanding square is a point. That is your origin point, and that's the point you'll be well, not exactly circling by, but flying an expanding square off. And it really helps if you fly 90 knots of your ground speed, and if the wind isn't that bad, you can just fly 90 knots of indicated airspeed, and it will not give you a lot of error. And usually we do expanding squares close to the ground, where your indicated airspeed is almost the same as true airspeed, and with calm winds, you can just use your indicated airspeed. So that's what we'd be using here as an example for simplicity. So when you fly 90 knots, your turn radius is half a mile. And that's an important thing, because we would be leading our turns by half a mile. Meaning, after you have crossed the point, you'll be flying on your original course, and that would be also in the OBS mode. So you would turn the OBS mode, and then you would select your first course. And I recommend flying cardinal directions. Like, in this example, you start with track of 360. And the reason is it's just so much simpler, because it's 360, 270, 180, 090, and back to 360. So you don't have to add 90 degrees every time you need to turn, and then do the proper math when you go over 360. So if you're good at math, you can start your expanded square on a track of 0.53, and then just start adding 90. Or if you're like me and you try not to do a lot of math in the air, just use cardinal directions. Usually it's not a big deal. There would be always a cardinal direction closest to you when you're approaching the point. So so we pass the point, and now we would be looking at our distance. And when you see it's half a mile, that would be time to start your turn. Left or right, of your discretion. In this example, that's a left turn. And now, remember, as I told you, that your turn radius is half a mile. That means by the time you finished your 90-degree turn, you added another half a mile, and now you're 1 mile offset from your, well, for simplicity, we can call it x-axis. And your half a mile offset, your 1 mile offset on your y-axis, and half a mile offset on your x-axis. You would continue your turn because you're already 1 mile, and you just continue your turn, basically flying in a circle or an arc, more precisely. And then when you have done an 180-degree turn, you would roll wings level, and now you are 1 mile offset on the x-axis. And I also recommend to turn on your pointers, well, your an arrow that would be pointing to a GPS waypoint. So you know that you can do it in G1000. So it just gives you more situational awareness. So you know where the point is at the moment. So right now your point is to your left. After you have passed, well, you can do it when you brought your wings level, but I prefer to reset my OBS when I'm abeam the point. And the reason for that, because if you press on the course knob, it will set the arrow direct to the point. And when you're abeam it, it will pretty much set your course to what you need. So in this case, that would be 090 because you would be flying east. And now you need to start your turn at a proper moment. So you're aiming for 1 nautical mile offset, and remember that your turn radius is half a mile. That means you will lead your turn by half a mile, which is in terminal mode is 1 dot. So when you see that your 1 dot deviation, you will start your turn, and your goal is to roll out when the CDI needle is 2 dots or 1 mile. So now you know that you're 1 mile. Now you would be on the bottom or on the negative side, so to speak. And so you're now offset 1 mile minus 1 mile on y-axis. And then again, you would reset your course. This time it would be 360, and you will lead your turn by 1 dot, and you will roll out again at 1 mile offset. And now you're flying 360 again. And since you started 360 and you're flying 360, that means it's time to add another mile because our spacing is 1 mile. And you still would lead your turn by half a mile. So if you want to be wings level at 2 miles, you need to start your turn mile when you see 1.5 miles on your course deviation on your HSI cross-track. And at that point, you will not be using dots anymore. You will be just using numbers. And again, much like with grid search, you would use either your magenta diamond or your track and desired track to make sure that you're flying proper course, and you can adjust your heading accordingly. And you will just continue doing it until you are again facing north on a 360 course, and then you will add another mile and repeat. So that's how your actual ground track will look. And here are examples of expanding squares flown with different spacing. Here it was flown with half a mile spacing, and that's more tricky because here you cannot do standard rate. You will have to do double the standard rate to do the first turns, and then at that point it would be standard rate again. Just here it just would be too tight because your first offset would be half a mile. And here's expanding square with 1 mile spacing. So, and that was flown by hand. It's not autopilot. I just flew it myself, just using the method I described. And if you do it right, and if you're focused on your track and your heading, you can fly that expanding square the way it would look almost perfect. And if you look closely, you will see some imperfections here, but more or less, it's almost as ForeFlight will do it for you. All right, so our next search is a sector search. The idea of a sector search is that you would fly over one point, but from a different directions. And the reason for that might be terrain. For example, if you fly it like that, you will be facing a mountain, and then you cannot see what's behind the mountain. But when you go do this triangle, now you'll be flying from the opposite direction of the mountain. So you'll be flying at it, and it would be much easier to spot things at the foot of that mountain. Another reason might be lighting, like you might have a shadow, or maybe you have sun in your eyes. So flying over that point from different directions would be beneficial. Plus, when you're scanning, you'll be covering a lot of area just doing those searches. And that's how it looks. So you would fly 3 triangles. It looks like a radioactivity sign, but realistically it's 6 sectors, because you would be doing like there would be 3 sectors that you fly and 3 adjacent sectors, which you still would be searching in when you fly. And again, here you will start with 1 point, and you would use OBS again. You would overfly the point on, again, a course of your choosing. Cardinal directions are easy, but here you will not be able to do north, south, west, east like you would in an expanded square, because here you don't have 4 turns, you have only 3 turns. So your turns would be not 90 degrees, but 120 degrees. And you will start with overflying the point, and notice that triangle pointing backwards. And so does the cyan arrow. That tells you that you flying from the point. And then there are 2 ways you can do it. You can do it as distance, or you can do it as time. So you can start the clock, and then you will do the turn after you have flown for a minute or 2 minutes or 3 minutes, or you can do the same thing using distance on your avionics. In any case, when you decide it's time to turn, you will make the turn. And remember, I told you it would be a 120-degree turn. And in this example, if you started with a ground track of 360, your next track would be 120. And the important thing to remember that, again, you can turn left or right, but after you have made your turn, you must turn the same direction every time. So if you turn right, all your other turns would be to the right. If you turn left at some point, you will screw it up. And there are also several ways to proceed from that point. If you want to do it in an easy way, so let's say you started it with using time. You flew for 2 minutes, and then you turn, you can fly for another 2 minutes, and then turn back to the point. Or if you want to be precise and you want to make your sectors pretty, then you would set your OBS to your next course. And here's the example. And your next course would be 240. And when your needle is about to center, you will start your turn. You will do another 120-degree turn to the right, because you started turning to the right. And then you will fly on the course of 240 direct to your point again. Then you will overfly it. Again, either use distance or time, turn again. Here's your second sector, and then do it one more time. And then when you're done, you'll be on your original course. It doesn't matter which course you started from. You should roll out on the same course, flying towards the point in the end of your 3rd sector. And it's pretty easy to do when you have well, 6 sectors, or it depends. Some people would say it's 6 sectors. Other people say it's 3 sectors because you actively fly only 3. But in A, regardless of if it's 3 or 6, when you start adding more sectors, it becomes more and more complex. So in this situation, you can see that you would be flying, sometimes you will be flying through, and so you would fly here, here, then here, then here, here. And it's much harder to figure out what to do in this situation. But the good thing is we never do more than 3 sectors or 6 sectors, whatever you prefer calling them, just for convenience. Our next search is creeping line search. And with creeping line, you have an origin point and a direction in which you would be searching, and you will be flying perpendicular to that direction, to the right and to the left of it. It's like S turns around the road, which you did during your private pilot training. But the idea is to do a thorough search in a very narrow area on the right and on the left of that course. And one of the most common uses for that search would be looking on final for a runway. Like, you know that an airplane was maybe flying an instrument approach and then it crashed. Well, it crashed somewhere along that line. So maybe it deviated a little bit, but it's somewhere within that narrow corridor. So that's why you would use the creeping line. And for the creeping line, well, you would start, of course, with the point of origin. In this situation, we want to search along the final for runway 24 at State College Regional. And that would be the first point you would create and add to your flight plan. Then you would create a second point, and that point needs to be created far, far away from your original point. So why far away? Well, let's go back to this picture. You can see that when you're here on the line, the distance to your points of origin would be your offset. But when you're at the corner, at the end of your leg, now you don't have, you have a slanted distance, right? So it's a right triangle. So you need to find your hypotenuse. And again, it's math and it's too much thinking. There are tables which you can actually make yourself, and then you can use those tables, but it's just not convenient. However, if you create a waypoint which is way, way out there, then there would be no significant distance between the slant range and your projection distance on your course, your direction of your search. So that's why we create another waypoint. And that waypoint would be created along the course you would be searching on. So in this example, if you're going to look on final for runway 24, well, first of all, if you look at the publications, you will find out that the actual magnetic heading of runway 24 is 244 degrees. Since you will be doing a search on final, you would be essentially flying away. So you would be flying on a reciprocal heading, which is 064. So that's your heading or your radial when you start creating a waypoint. And your distance I use 99 miles. Some people use 100, but you don't want something out there. You don't want to have it 1,000 miles because then you will not have decimals, and you want to have decimals. So you will have decimals only if you are less than 100 miles. And as you should know, you can create a user waypoint in both 650 or G1000 using reference point radial distance method. So your reference point would be KUNV, your radial would be 064, and your distance would be 99. And after that point has been created, you will add it to your flight plan, and you can proceed direct University Park, or you can keep it as a lag. But essentially what you want to do is you want to fly over the point perpendicular to your course. So in this example, you'll be flying southeast, and 64 plus 90 is 154. That's the course you will be flying. Keep in mind, that's course, not heading. Here, again, Garmin simulator doesn't simulate wind, so your course and heading is always the same thing, but that's the thing you need to keep in mind. So make sure that you're flying 154 ground track and not heading, and the heading should be whatever it has to be to fly 154 over the ground. And then you'll be looking at your course deviation needle again. So if you have a 1 nautical mile lag, so that would be half of it would be on one side, half on the another side. That means that your part of the lag would be over when your half of the lag deviation. So if it's 1 mile lag, when your half mile deviation, that means your observer and your scanner can stop scan, and you can either start your turn immediately, or I usually would fly a little bit more outbound so I can turn around without the fear of wind blowing me towards the center line, and then I will not be half a mile offset, I'll be less. So if you have a headwind, you would fly a little bit forward before turning back. If you have a tailwind, you can start your turn right away because the wind will move you more off course. And again, in terminal mode, your half mile deviation is 1 dot. Then you would keep your turn going, and then at that point you would be looking at your distance. So if you started with 99 miles, your distance would be decreasing because you're flying towards your the other point that you created. And when you're halfway in the turn, you should be half the distance off. So if it's a 1 mile spacing, you would be 0.5 miles, or in this example, you will see 19.5 on your screen. And then you need to roll out at 98 miles. So you started with 99, now you're 98, you will cross your center line again, and then you will turn again, and you will roll out at 97 miles, and so on. So here's the summary. Both Garmin G1000 and GTN 650Xi offer features that can help pilots plan while in the air, eliminating the necessity to do calculations on the go. And that's an important thing because there are other ways to fly those searches, but they would require either the use of tables with distances or doing calculations in your head, which is not advisable when you're flying 1,000 feet above the ground, trying to dodge birds. And also the basic features of both systems can be used to fly a variety of searches even without a SAR package installed, which, as far as I know, none of our 182s have a SAR package installed. And that's also preferable over using ForeFlight, because ForeFlight is very helpful, but building searches in ForeFlight takes time, and that would be time heads down. What I demonstrated to you in this presentation is you can build it very fast. If you're proficient with your avionics, you can make points very fast. You can also ask your observer to make points, and it's much easier, much faster, and much safer than messing with your tablet. All right, thank you for your time.